Hello friends, in this video we will see and we will have a more clarity on magnetically coupled circuit by solving some numericals based on the same. In magnetically coupled circuit, they ask you the questions for calculating L equivalent for the given circuit. For example, let's say there are two inductors which are connected in series. For this I can say L equivalent is simply L1 plus L2. Is that right? But for example, in the question, if they have provided like this, L1, L2 along with some dot is given, what does that indicate? It indicates there is a mutual coupling between the same. In case L equivalent will not be only L1 plus L2. Of course, L equivalent will have a part as L1 plus L2, but that's not the final answer. So possibility of these dots can be like this. I'll make you understand how to interpret these dots. All possible dot positions we will see. So let's say first, second and third. Talking for first example. You see some dots there, right? And between these two dots, there is a mutual coupling. This indicates there is a mutual coupling between L1 and L2. You can do one thing, just send some current through L1 and just check for L1, is it entering into dot first or it is entering into the coil first. If it enters into dot first, it is considered as entering by the dot. Even for second coil also, it is entering by the dot. When it is entering by the dot for both, L equivalent is given simply as L1 plus L2 plus of twice of M, where M indicates mutual coupling. For example, let's talk about second example, L equivalent. As I said earlier, just send some current. For coil number 1, you can check it is entering into the dot first. Therefore, for coil 1, it is called as entering by the dot. When the same current progresses ahead, it doesn't enter into dot first, it enters into coil first, and from the dot it actually leaves. So for first coil, it is entering by the dot, and for second coil, it is leaving by the dot. Can you see, one is entering, the other is leaving. In that case, it is L1 plus L2 minus of twice of M. First example, you must have seen, this is entering. When it is entering, it is plus 2M. When it is entering leaving or leaving entering, it is minus 2M. Let's see for the third example. Send some current through this. As you can see, it enters into L1 first and then from dot it is leaving. So for coil 1, it is leaving by the dot. And for coil 2 also, current enters into coil first and it leaves by the dot. So for second also it is leaving. When it is entering, leaving, it is plus 2M. Therefore, L equivalent, it's simply L1 plus L2 minus 2M. Based on this, now we can have one numerical. We'll see how to go about this. You have to find L equivalent between point X and point Y. You can consider this as point X and this as point Y. You have to find L equivalent between all. As you can see, 4, 6 and 8 are connected in series. So first of all, I can say L equivalent is first of all 4 plus 6 plus 8. Along with that, we have to also see their mutual inductances also. This 1 Henry is between coil 1 and coil 2. Let's say this is L1, this is L2 and this is L3, right? So this is a mutual induction between 1 and 2. I would say it is M12. Between 2 and 3, it is 2 Henry. So it is called as M23. Even if you call M23 as M32, it doesn't matter. That sequence is not mattering. Only what matters, you should show both the numbers here. Remaining 3 Henry is between coil 1 and coil 3. Then it is called as either M13 or M31. I'll call this as M31. So I'm sure you got 3 mutual inductances here. Now, as I said, between coil 1 and coil 2, first of all, we will see by sending some current. So for coil 1, it is entering by the dot. And for coil 2 also, it is entering by the dot. What does that mean? It will be plus 2M or minus 2M? Plus 2M. So what I supposed to say? It is actually L1 plus L2 plus L3 plus, for L1, L2 I am talking about, it would be plus 2 M12. So I am done with this M12. After that, for coil 2, it is entering by the dot. For coil 3, it is leaving by the dot. As you can see, for coil 2 and coil 3, if you refer, one is entering, other is leaving. What does that mean? It should be minus of 2 M23. That is just a comparison of 2 and 3. Let's compare 1 and 3 now. For first it is entering, for third it is leaving. Again one is entering, other is leaving. What does that mean? It should be minus of 2 M31. L equivalent becomes L1 plus L2 plus L3 is 4 plus 6 plus 8 plus twice of M12. M12 is 1 minus twice of M23, and M23 is how much? It is 2 minus twice of M31, which is 3. Just solve this L equivalent. You will get L equivalent as 10 Henry. I'm sure you have understood this sum. We'll go for the next sum now. We have to find L equivalent between A and B. The matter of fact that here L1, L2, L3 values are not given, as well as mutual inductances are not given. We will assume them. Connection between 1 and 2 can be taken as M12. Connection between 2 and 3 can be taken as M23, and connection between 1 and 3 will be taken as M31 or M13. Is that right? Since L1, L2, L3, M12, M23, M31 values are not given, we will assume or we will calculate L equivalent in terms of L1, L2, L3, M12, M23 and M31. Let us verify. The problem here is even dots are not given. Since dots are not given, we have to find. When dots are entering, we used to take plus 2m. When dots are entering, understand their actually fluxes are helping each other or assisting each other. Whenever two coils are having separate flux, but if both the flux oppose each other, then the flux subtraction takes place. Just to show that flux are getting subtracted, we indicate one is entering, other is leaving. When one dot is entering, other dot is also entering, it means both the flux are going to assist each other. The problem is, since dots are not given, at least flux direction should be known to us. But again, flux directions are also not given. What is actually given is a current direction. From current direction and by using right hand rule, we can actually understand how to go about this problem. Let us verify. We have to use a right hand rule. I'm sure you remember right hand rule. For example, so you have to use a right hand rule where, let's say you have a conductor, and if curl of finger indicates flow of current, then the direction of thumb indicates a flux. So by using the same, suppose the current is flowing in this direction, this is the flow of current. Is that right? Now this is actually curl of fingers. If this curl of finger indicates a current, this thumb will indicate what? Flux. Moral of the story, the flux for coil 1, as you can see, it is in upward direction. I would say it is phi 1. Let's talk about L2. For that, a current direction should be known to us. As you can see, the current will come like this. It will flow in this direction. Is that right? Again, what you do is, you just take a conductor and this curl of fingers indicating a current direction, this thumb indicates flux direction. That's the reason why I can say this is flux direction phi 2. The same current is progressing here and it is going in this direction. Is that right? As you can see, the circuit is completed from A to B. Again, for the third, you can see that is third coil. As you can see, this curl of finger is going to show you a current, then this thumb direction is your flux. Now observe phi 1 and phi 2. Phi 1 and phi 2 are in same direction or opposite direction? They are in same direction. So phi 1 and phi 2 will assist each other. Please indicate this like this. Phi 1 and phi 2 will assist each other, meaning that this flux addition will take place for coil 1 and coil 2. Coil 2 and 3 I am talking about. Coil 2 and coil 3. Check out what is phi 3 direction. Phi 3 direction is upward. Phi 2 is going towards left hand side. It means they are flowing in opposite direction. So here phi 2 minus phi 3 or phi 3 minus phi 2 will take place for coil 2 and 3. For coil 3 and 1, you can see phi 1 and phi 3 are opposite direction, are in the opposite direction. Like phi 1 is going in this direction and phi 3 will go in this direction. It means they are in opposite direction. So even subtraction takes place for 1 and 3. So phi 1 minus phi 3 or phi 3 minus phi 1, whatever you write, both of them are correct. One cannot deny the matter of fact that L1, L2 and L3 are in series. So obviously L1 plus L2 plus L3 will come by default. Let's talk about coil 1 and coil 2. If you remember, if coil 1 and coil 2's flux are assisting each other, it will be twice of M, and if the flux are opposing each other, it will be minus 2M. So for coil 1 and coil 2, as we have seen, a flux addition is taking place. Therefore, it will be twice of M12. Let's talk about coil 2 and coil 3. For coil 2 and coil 3, as you can see, we have seen flux is getting subtracted, so it will be minus 2m. So it will be minus of 2m23. Last, that is coil 1 and coil 3, as you can see, both the flux are getting subtracted. Therefore, it will be minus of 2m13. And this is how we calculate L equivalent. If the values of L1, L2, L3 and M12, M23 and M31 were given, we could have come with a numerical answer. But again, here since values are not given, we can calculate L equivalent like this only. I'm sure you understood this concept. We'll move to the last problem now. Let's see this question. Find the coefficient of coupling. Coefficient of coupling means coupling factor, that is K. For the following circuit at resonance, they have said that it is going to occur a resonance condition here. So at resonance, what really happens? At resonance, we should know that magnitude of XL and magnitude of XC is always equal. Of course, XL equal to XC also we can write. So here, as you can see, XC is given as 12 ohms. Is that right? It means XL should match with 12. But then here J8 and J8 are connected in series. Am I right? And now look at these dots. This dot indicates there is a mutual coupling between both. So if you made some current to flow through this, for coil 1 it is entering by the dot and for coil 2 it is leaving by the dot. What does that mean? It means the relation will be like this. L equivalent between L1 and L2 is L1 plus L2 minus of twice of M. Or you can write this also as XL equivalent should be equal to XL1 plus XL2 minus twice of XM. Am I right? What is XL1 provided? As you can see in the figure, it is given as 8 plus 8 minus twice of XM. This is not known to us, so I'll keep this as XM. The value of XL equivalent. We know that XL equal to XC should happen at resonance. At resonance, as you can see, XC value is given as 12. It means XL equivalent should also become 12. It means the value of XL equivalent is 12. If you solve this, you'll get the value of XM as 2 ohms. So now what I can see is, we can concentrate on this circuit. If you remember, this is XL1, this is XL2. It was like this. It was J8, J8. Also, we got a mutual coupling between them and it is J2. Is that right? So, XL equivalent in this case will be XL1 plus XL2 minus of twice of XM. Is that right? Or in fact, I can write this as XL1 plus XL2 minus twice of. I'm sure you remember XM formula. In fact, we derived it from M formula, which is K into under root of L1 plus L2. Then XM can be written as K into under root of XL1 XL2. Am I right? So in that case, this XM can be written as K into under root of XL1 XL2, which should be equal to XL equivalent. So if you remember, at resonance it should become 12. So 12 is equal to XL1 was 8, XL2 is also 8 minus twice of K into XL1 XL2 are 8 into 8 here. So if you solve this, you'll get K value as 1 by 4. This is nothing but a coefficient of coupling. So I'm sure you have understood how to find coefficient of coupling, and now you are quite comfortable with mutual circuits or magnetically coupled circuits. Thank you.